Guys, welcome to my channel on Tech Chronicle with Swastik. In this channel, I will going to give you the latest updates regarding computer science and about the upcoming courses in my channel. Today, I am going to tell you about database management system, that is DBMS full course. Today in this lecture 26, you will going to learn about lossless join and dependency preserving. In this class, the today's agenda for lecture 26 is that lossless join and dependency preserving. Here you will going to know about lossless join decomposition with example. Second one is lossy decomposition with example, and the third one is dependency preserving with example. Now coming to the first one, that is lossless join decomposition. Consider there is a relation R which is decomposed into subrelation up to R1, R2 up to Rn. This decomposition is called lossless join decomposition, where the join of the subrelations result in the same relation R that was decomposed. For lossless join decomposition, we always have R1 natural join R2 natural join R3 up to natural join R1 is equal to R. Now coming to the example of lossless join decomposition, let's take the original table, which is the employee project table, which consists of employee ID, project ID, employee name and project name. Now let's decompose this table into two relations. The relation 1 will be employee detail, which consists of employee ID and employee name. The relation 2 will be of project detail, which consists of project ID and project name. To check if this decomposition is lossless, we need to perform a natural join on the common attributes in employee ID in this case. If the result of the natural join is equal to the original relation, then decomposition is lossless. So now the natural join of employee details and employee project details, the result of the natural join is same as the original table, that is of employee table. See, this original table and the natural join table both are same. Okay, therefore this decomposition is lossless because we can construct the original relation by joining the decomposed part. Lossless decomposition is essential that we can maintain the integrity of the data when decomposition relation into smaller parts. Coming to the second one, that is lossy decomposition. Consider there is a relation R which is decomposed into subrelation R1, R2 up to Rn. This decomposition is called lossy join decomposition when the join of the subrelation does not result in the same relation R that was decomposed. For a lossy join decomposition, we always have R1 natural join R2 natural join R3 up to natural join Rn, which is proper superset of R. Now let's come to the lossy decomposition example. Let's consider an example where the original relation is employee project, which consists of employee ID, project ID, employee name, project name. Now let's attempt the lossy decomposition into two relations. The relation 1 contains employee details, which consists of employee ID, employee name. The relation 2 contains project details, which consist of project ID and project name. In this decomposition, we lose information about which employees are assigned to which project. We can reconstruct the original employee project relation because the connection between employees and project has been severe. If we attempt to join these decomposed relations based on employee ID, we cannot recover the original information about project. So after joining employee detail and project detail, the table is not equal to the original table. As we can see, the information about project ID and project name for the employee ID 3 is lost. This is an example of a lossy decomposition. It is important to avoid such situation in database design to maintain data integrity and ensure that the original information can be accurately reconstructed from the decomposed relation. Now coming to the third one, that is dependency preserving. If we decompose a relation R into relation R1 and R2, all dependencies of R either must be a part of R1 or R2, or must be derivable from a combination of functional dependency of R1 and R2. This is the example of dependency preserving. To illustrate a dependency preserving database design example, let's consider a scenario involving the normalization of a relation into 3NF. The original table is of student courses, which consist of student ID, course, professor, and department. In this table, we have information about student, the courses they are taking, the professor teaching those courses, and the department associated with each course. The candidate key for the table is student ID, course, and there is a transitive dependency between student ID and department through course. Now let's normalize this table into a 3NF to achieve dependency preservation. Step 1, we have to remove transitive dependency. So now the table 1, that is student courses, consists of student ID, course, and professor. Now come the table 2, that is course department, consists of course and department. Now the transitive dependency is removed. Student ID determines course and course determines department. Both tables maintain the original information without introducing redundancy. This is an example of a dependency preserving decomposition, because we have maintained the dependencies between attributes while achieving normalization. The relationship between student ID and course and professor, and course and department are preserved in the decomposed table. Dependency preservation is a fundamental principle in database design to ensure that relation and information are accurately represented and maintained. If you like the video, then like, share and subscribe to my channel. Thank you. That's all for this lecture.